Now we are going to discuss about the properties of the dot product or scalar product. The very first one is known as the commutative property. For defining the commutative property, we will take two vectors. One is known as A, the other one is known as B. Here, always A dot B and B dot A, the dot product becomes equal. So, commutative property will be satisfied. So, A dot B is equals to B dot A. Coming to the second one, here we are going to take three vectors. One is known as A, the other one is known as B, while the third one is known as C. Now, A dot B plus C can be written as A dot B plus A dot C. We will call this one as the distributive of scalar product over the addition. So, we can call it as a distributive property. Next one is known as about the third one, where here along with the two vectors a and b, we can take one more vector, one more scalar, we'll call it as a lambda. Now, the here lambda into a vector dot b vector, here lambda is a scalar, that is nothing but a real number. Lambda can be made it as a keeping outside, and we can do the scalar product between the two vectors. So the value will be remains the same. Lambda a vector dot b vector value is nothing but the value which you are going to get by taking the dot product between a and b multiplied by lambda. Both the values will remains same. So here lambda into a dot b is equals to lambda into a dot b. Now here I'll show one small example. In the place of lambda, I will take 2. This can be written as 2a dot b is nothing but 2 into a dot b. Here we'll write 2 is a scalar because 2 is nothing but a real number. It makes no difference. Coming to the fourth one, along with the two vectors a and b, we will take two scalars. One is known as L, the other one is known as M. So LA vector dot MB vector is equals to, we'll keep the L and M outside, we'll multiply those two. Then we'll take the dot product between the two vectors, that is known as A and B. The value remains same. Therefore, LA vector dot MB vector is equals to LM into A dot B.